Well, I mean, there's a lot of questions that I have, of course. Some of them are very academically oriented, but I also want to try to have a conversation that can be that has some application for people who are listening. And so I figured maybe we could talk a little bit. And I know you talked about this quite a bit in other settings, but if we can talk a little bit about plasmalogens, which is one of the hallmark features of what you've been working on in terms of products. And what separates them from other lipids, because these are a class of lipids, these are a class of phospholipids, and there's a lot of different supplements. But there's something very unique. There are some things about them that are very unique, and of course, all of these different lipid supplements are very important. But yeah, if we could talk a little bit about
Sure.
what plasmalogens are.
Yeah, so plasmalogen, like, it's an interesting topic because what this serves in the acute inflammatory syndromes that people are suffering from. You have to remember that these are not isolations, right? Like, we do know even in emergency rooms, when someone gets a UTI, they'll get cognitive issues, right? So any kind of acute infectious disease can have dramatic effects. So this is not, it's not a surprise that if you have a hyperinflammatory or hyperimmune response to either a tick or mold or whatever, or a vaccine or anything that happens in your life, the symptomology is going to be common across anything. So it's whatever you personally become negatively affected with. And so we talk about plasmalogens in the context of cognition and multiple sclerosis and things, but because most people don't really talk about the inflammatory immune system with plasmalogens, which they play a very critical role. So backtrack, what are these things and where they come from? We originally found them in the early 1900s, I think 1919 or so, when plasmalogens were first discovered. But their role really wasn't started to heavily be understood until the 70s. We had some plasmalogen precursors in the 60s, like chymal alcohol, battle alcohol, salicial alcohol, actually used in the cosmetic industry, for example. But in the 70s, there are certain genetic diseases, such as Zellweger syndrome, rhizomelic chondrodysplasia, and others, that these were diseases in which the manufacturing of plasmalogens were impaired, and they resulted in severe neurological consequences and mortality, making it very clear that adequate plasmalogen manufacturing and sustenance in the human body is a critical component. We've already known since the 60s, basically, about breast milk, and that certain alkyl glycerols, which are plasmalogen precursors, are in various concentrations from cow's milk versus goat's milk versus human's milk. And so human milk has naturally high levels of these omega-9 alkyl glycerols that turn into plasmalogens. So plasmalogens, as a molecule, they are a phospholipid typically in your body, what we talk about, which makes up all the membranes. So your body has 30 trillion cells, if you will, right? And the membranes are made up of those molecules, lipids, these phospholipid bilayers. And plasmalogens are a critical component of that. In both your heart, your lungs, all cells of your body have very high levels of plasmalogens. And these molecules aren't dietarily obtained, other than you get a little bit of it in breast milk. So most of it we get from our own endogenous manufacturing capacity, which is why these particular genetic diseases had such negative consequences, because there was no backup plan. Okay, there was no way of actually taking more nutrition to get these plasmalogens, because the human body makes them themselves. And so that's kind of where, as you fast forward through this process, I come into the scene in the early 2000s, developing this ion cyclotron mass spec technology that can measure thousands and thousands of molecules. So I wasn't the person who invented plasmalogens, but I was, when I looked at these large community and clinical trials that we're involved in with dementia, multiple sclerosis, Parkinson's, and cancers, it became very clear that this deficiency in plasmalogens was heavily related to the incidence of these diseases. And more research showed that these were prodromal, that these low plasmalogens were contributing to the future incidence of these diseases, which led to, because my background is in neuroscience, but I'm also a synthetic organic chemist and a medicinal chemist. So it led to saying, well, if we're having this deficiency, why can't we just replace them? Well, it sounds like, and it became a more difficult challenge than originally anticipated. So a lot of research went into finding out these precursors that we could deliver like human breast milk. And when we made those molecules, invented them and started manufacturing them, and we used them in animal studies and others, we had dramatic results. We could completely prevent Parkinson's. We can prevent multiple sclerosis in these animal studies. And so clearly they're very powerful biological effect. And so that leads to the question is, well, what are these things actually doing?
Mm-hmm.
And how much do we actually need? And in the context, like we talk a lot about neurodegeneration because the brain shrinks. So what I was showing at RADFest and is with these plasmalogen precursors, I was able to reverse 20 years of brain aging. I was basically able to refill the white matter that I had lost in my brain, even from my 40s to my early 50s now. And that is objectively measurable with advanced MRI type technology. And we have obviously evidence of people's heart structure and function. One of the most common things people see is that their lung and breathing improvements, which is critical in these respiratory infectious disease syndromes that we're dealing with, right? It affects everybody. So, and then once you've kind of discovered this, then you can kind of go back in time and look at other people's research, right? And so these alkyl glycerols, one of the places that they're found is in sharks. So sharks are one of the rare animal that has they're kind of immune to infections. And so you can isolate certain plasmalogen precursors from shark liver oil. Obviously it comes with a bunch of other stuff. So we manufacture highly purified versions of this that can target certain parts of your brain and things. But even then, if they did fancy extraction and if they isolate these alkyl glycerols from shark liver oil, and you give them to people, they don't get the flu, for example. So clearly immune modulation and the endothelial barrier perspective. So we talk about other people with, like say, ulcerative colitis or leaky gut syndrome, all these things we talk about, right? So when we're talking about the membranes of cells, those 30 trillion cells, when we're talking about these also make up the barriers, right? So when one of the biggest things with these inflammatory syndromes is that the cell-to-cell connections get disrupted and they open up and they allow proteins to go, and this is what causes, say, atherosclerosis, for example. That atherosclerosis is a disease where the endothelial layer of your vascular system becomes inflamed. Hear that word again, inflamed. It comes all, so what does inflammation do? It actually causes the cells to lose some of their plasticity, their functionality, and then things can leak in between the membranes, which we call leaky gut syndrome, or in atherosclerosis, it's the LDL molecules, oxidized LDL going in between the endothelial layers. So things that modify and improve the structure and function of the membrane improves that. And they've actually shown that alkyl glycerols, which is what proton glia and proton neuro are, they actually tighten the membranes back up. Like they'll prevent endothelial leakage. And so we use this a lot of times, like for ulcerative colitis. I recommend always like the omega-9 plasmalogen. We use the curcuminoids, which are also very potent anti-inflammatories. And there's some peptides that work. But so we're now at the point where we have a high success rate in terms of this leaky gut syndrome, and which is one way of reducing the inflammatory load. And then the other side of the coin is how do you fill your tanks back up? Because by the time you're experiencing symptoms, right, you've already been drained, if you will, right? Like, because all what we're really talking about is this acute inflammatory response is creating a load on the human body. Like wherever it's coming from, you're dealing with an excessive metabolic load, and then other parts of your cell come into play, like your mitochondria, the peroxisomes, where these plasmalogens are made. And we're dealing with lots of, talk about 50% of some of the lipids of your heart are these plasmalogens. Your lungs, your brain has high levels. So that's basically the short story of plasmalogens. It's one of those. It's the most important nutrient that no one knows about because it's really kind of a vitamin almost if you think about it.